Pesticides, Their Chemical Structure and Their Properties by Lainey Ruffiner. According to the National Institute of Environmental Health Science, pesticides are considered any substance to control, repel, or kill plant or animal life that is considered to be a pest. Pests come in many forms, including weeds, rodents, insects, and fungi. Sometimes microorganisms can even be considered pests. Each type of pests have specific pesticides, like insecticide for insects, herbicide for unwanted vegetation, and rodenticide for rodents. The chemical structure of these pesticides can vary greatly. 4 main groups of pesticides exist when you classify them by their chemical structure. These include organochlorines, organophosphorus, carbamates, and pyrethrin and pyrethroids. Organochlorines were one of the first pesticides used in agriculture. They are mainly used as insecticides, but predominantly work on vertebrates. Because they are hard to degrade chemically or with microbes, they stay around a long time and can be harmful to the environments they are used in. Organochlorides work by causing seizures, paralysis, and eventual death in their target pests. Some examples of this kind of pesticide include DDT, lindane, endosulfan, aldrin, dieldrin, and chlordane. Organochlorines usually contain 5 or more chlorine atoms. Organophosphates are another group. Similar to organochlorines, they are mostly used as insecticides, working on both vertebrates and invertebrates. These compounds are easy to decompose, so they are better for the environment they are used in. This type of pesticide blocks neurotransmitters and causes rapid involuntary movement of muscles, causing death. Some examples are named below in the table. Organophosphorus pesticides usually have a phosphate component. Another group of pesticides is carbamates. These kill their target pests in a similar way to organophosphorus, but we'll go into detail on that shortly. Carbamates are used mainly as insecticide and rodenticide. The environmental impact of these carbamates varies with their chemical structure. Pyrethrins is an interesting group of pesticides. Pyrethrins are naturally occurring and are found in pyrethrum flowers. Pyrethroids are synthetic versions of these pyrethrins. They are mainly used as insecticide, and they degrade easily in their environments when they are exposed to light. Organochlorines contain carbons, hydrogens, and chlorines. The model shown is a simple lindane molecule with a carbon ring. Each carbon has a chlorine and a hydrogen attached. This is an example of an organochlorine pesticide. Because these chlorine-carbon bonds are hard to break, organochlorines do not decompose easily. Although chloroform was mainly used as an anesthetic when it was discovered, it was also used as a pesticide. Chloroform is an example of an organochlorine, with 3 chlorine, 1 carbon, and 1 hydrogen. It causes death in insects, but in humans it causes drowsiness or an unconscious state. Because it is an organochlorine, it is hard to decompose. Organophosphorus pesticides have a very specific structure. They contain a phosphate group as their structural framework. This diagram, courtesy of intechopen.com, shows the structure of these compounds. The R1 and R2 are usually methyl or ethyl groups. The X group can take a wide variety of forms. The bonds in these compounds are easier to break, therefore this chemical pesticide is easier on the environment and decomposes more readily. The chemical structure of parathion is shown on the right with its carbon ring in black attached to a nitrous dioxide, 4 hydrogens, and a phosphorus trioxide molecule with 2 attached CH3 groups. Carbamates also have a specific structure. Shown on the right is a diagram of this structure. Of course, not all compounds in the carbamate group will have this exact structure, however, they should be similar. R1 corresponds to an alcohol group. R2 will be a methyl group, and R3 is most commonly a hydrogen. An example of a carbamate is carbofuran, with the model shown on the left. Organophosphate and carbamates work very similarly on the synapses of the target pests. During organophosphate and carbamate poisoning, certain receptors are blocked when the pesticide molecules bind certain receptor sites, rendering them useless. These receptors are called acetylcholinterase. They are meant to receive acetylcholine, which is then destroyed. Because of the chemical structure of these organophosphate and carbamates, they will bind to the receptor sites of the acetylcholinterase. Without working acetylcholinterase receptors, acetylcholine will build up, causing sodium channels to remain open and allowing sodium to pass through the channel and into the postsynaptic neuron. This causes constant stimulation of nerve endings and eventual death. This is what causes the twitching while an insect is dying of organophosphate or carbamate poisoning. Pyrethrins are another group of pesticides found in chrysanthemums and other pyrethrum flowers. Synthetic versions of these chemicals can be manufactured and are called pyrethroids. These chemicals are impractical, however, for use as an agricultural pesticide because they become easily oxidized in the sunlight. Pyrethrins target the nervous system by acting on sodium channels along the axon. The chemical structure of these pesticide compounds allows them to attach to the sodium channel and hold it in an open position. Sodium ions then flow freely through the channel, stimulating the nerve until they reach an equilibrium within the cell. At that point, there is no more electrical activity happening in the neuron, and it is no longer functioning. With this method of insecticide, you still have the classic twitching while the nerves are overstimulated, but there is a subsequent paralysis before the death of the insect. On the left, you see the chemical containing carbons, oxygens, and hydrogens. This acid is an organic compound. This compound is found in the seed case of the pyrethrum flowers. The natural chemical pesticide is an evolutionary response against predation for chrysanthemums. Thank you for watching my video on pesticides, their chemical structure, and their properties. My name is Lainey Ruffner in Chemistry 1301.